Sentence embedding refers to the process of representing a sentence as a vector that encodes its meaning and semantic information. It is a technique used in natural language processing to capture the context, intention, and relationships between words within a sentence. By transforming sentences into fixed-length vectors, machines can better understand the nuances and subtleties of human language. Sentence embeddings can be obtained through different approaches. The first approach involves using a pooling strategy, such as max pooling or mean pooling, to calculate the sentence embedding based on a collection of word or subword embeddings. The second approach utilizes the first token of the sentence as the sentence embedding in some language models, such as BERT. The third approach involves training or fine-tuning a model specifically to learn sentence embeddings. One example of this is Sentence BERT, which employs a Siamese network architecture with BERT as its backbone. When obtaining sentence embeddings, a pooling strategy is often used to calculate a fixed-length representation of the sentence based on a collection of word or subword embeddings. Pooling involves aggregating the individual word or subword embeddings to create a single representation for the entire sentence. Max pooling selects the maximum value from each dimension across the word or subword embeddings. It captures the most salient features or characteristics present in the sentence. This pooling strategy is useful when identifying important keywords or detecting specific patterns in the sentence. Mean pooling calculates the average value from each dimension across the word or subword embeddings. It provides a representation that captures the overall semantic information of the sentence. Mean pooling is commonly used when the goal is to obtain a general understanding of the sentence's meaning. The SELS token is a special token used to represent the entire input sentence when generating sentence embeddings. It stands for classification and is typically used in tasks that involve sentence-level classification or understanding. It's important to note that while the SELS token provides a useful sentence embedding, it may not always capture fine-grained sentence-level details, especially in cases where the sentence contains multiple distinct meanings or complex structures. The key idea behind SPERT is the use of Siamese networks. In this approach, the BERT model is placed in a Siamese architecture and fine-tuned on pairs of sentences. The Siamese architecture consists of two identical BERT models that share the same network weights. By training on sentence pairs, SPERT learns to generate similar embeddings for similar sentences and dissimilar embeddings for different sentences. To obtain a fixed-sized sentence embedding, SPERT applies a pooling operation to the output of BERT. Common pooling strategies include mean pooling and max pooling. Mean pooling calculates the average value across the dimensions of the BERT output, while max pooling selects the maximum value. These pooling operations derive a fixed-length representation that captures the overall meaning of the sentence. In summary, sentence embeddings can be obtained through pooling strategies, by using the first token in language models like BERT, or by training/fine-tuning models like Sentence BERT. Each approach has its advantages and can be applied based on the specific requirements of the task at hand. These sentence embeddings enable us to capture the semantic understanding and similarity between sentences, opening up possibilities for a wide range of natural language processing applications.